So for the rest of the code, it doesn't matter whether you put the last block at the front or at the end, or even if you somehow put it in between. That doesn't really matter.
Okay, because my naive at least idea to this at the bottom would be like sort of a filter.
Yeah. So which exercise are you?
This one. So I was thinking.
So to add it, yeah.
I was thinking like to.
Yeah, but I wasn't sure. I thought that was.
Wait. Let me just check, because I think in this case I assume that it's already been checked whether the
whether. I tried just adding them directly and I got it. And it doesn't seem. Oh, okay.
Oh no. Wait. So which one is it? Just to add it, right? Is that add T? Yeah. So when you add it, yeah, you don't just add the blocks, but you also need to move them to the correct position. That's important.
Why did we pick a float for the size of the board?
For drawing, because they need floats, and you could also take ints, and then it would be annoying for drawing and easier for the model.
Because effectively for us, the width and the height are concepts that are integers.
Yeah.
So we're making a trade.
You could. Yeah.
I just was just confused.
And actually, it should be better. It would have actually been better to take ints. Yeah.
It's alright. It's just wondering. It makes sense.
Yeah.
Oh, yeah. I haven't applied it to. So you don't need the F now.
I'm going to take some coffee. So you have this tetronimo. The first is the size of this square. The second is the position. And so you basically need to, but you implemented a move method, right?
Yeah, I know.
So
you. But where should I move it
to the position of the tetronimo. So let me show. Let me show this again. So this thing, that's the position relatively on the board. So if it's on 5, 0, and this one inside. So these are the coordinates inside of the grid. So in this case, this would be 1, 1, 1, right? But then we have moved everything over the x-axis, and so in this case we moved it 5 to the right, and so at this point it's 5 1, 5 1, right? 6 1, of course. So this is now 6 1, and so what we had to do is we had to take the position of the tetronimo. Yeah. Oh, yeah. And we simply added it to the coordinates which here, yeah. And this function you already implemented it because it's called move. And so if you add the tetronimo to the board, you should change the block positions. Okay, so for free block, who didn't solve this one yet? Everybody has solved it? You still, okay, cool. You have a board, yeah, and you have a certain block, yeah, and then so what you need to know is whether this block is inside of this board or not. And so a board itself, it's a list of blocks. Yeah. Here, a board, that's a list of blocks, right? So basically, and a block itself, where is the block defined? The block here, it's basically just a constructor block and then 2 numbers, right? And so the free block, what does it do? Well, it should basically check whether this block is already inside this list or not. Yeah, and so there is a handy function lm. And if you look at this type, it looks a bit complex, but basically it says you have an A and a T of A, then it's going to give you true or false, and so it's basically to check whether you supply that it's of A, and so E, it's what is called a foldable, but for us we can actually look. This is some element, and this is a list of elements. If this element is in that, then give back true or false. So if we do lm of 1 in a list 2, 3, 4, what will we get? Of course. And if we add 1 to it, we will get true, right? So then for an insight, this block, we told Haskell, well, derive us the equal type class, which means that if it has two blocks, that it automatically knows how to compare them. That's if you don't put this EQ, the was not going to work. Yeah. So let's go back and then look at the solution. So this is the solution, and I will hide this one. So basically, if we know that this B, so we should negate the fact that this B is an element of the list, yeah, because if it's not an element of this list, it means that there is that B is still that you can still place that block onto this board, and that's the idea. Is that clear?
Yeah.
Okay. Cool. So which challenge did you take up on yourselves? Like
intermediate.
Intermediate? Cool.
Yeah, same. Hardcore.
Hardcore.
I'm gonna try it. Go big or go home.
Cool. And you?
I'm doing the last of the beginners and then
Cool.
switch to something.
Cool. So, but did you finish then, or what?
I'm on the check row, so that's the last.
That's the last one. Cool, cool.
I'm not sure yet. I want to see how the sort of idea of taking a monad and like, I forget what the operation is called, where you use all available memory on the earth and then duplicate. Yeah, duplicate. Yeah.
I was actually talking to him yesterday evening, and it would be super easy to take this game of life and add a gloss interface to it, right?
Yeah.
So we will do this afternoon.
Nice.
We said, but I think it's so simple that it would also be a nice challenge for yourself to add this.
Don't run it more than 5 or so frames. Yeah, I want to see if he's got sort of like, this is how you sort of make it all lazy and cache results and stuff like that, so that it's not going to be very, very expensive.
It's interactive. Right now it's interactive. It says you have to use some sort of functor or representation of functor, something like that. You know,
Well, I was not in the.
That's what it said, right? We
I
don't know what it is.
I was not in his track, so I don't know exactly what he was.
Finding the result for one square takes 8 to the power of the number of frames you want to compute.
Okay,
So
let's see. It's always surprising how, if you have a database with like millions and millions of records, it's like peanuts. You really have to go up till billions and billions, and even then, it's like you find it fast.
Just one thing I think could be nice on this system in general is to have an abort thing. Like right now I realized I had used the same name twice, so I was like, just after pressing submit, I'm like,
It's asynchronous, so you can just switch to your tab.
okay, right.
So, and you can start working on it again, but it is going to finish. It's not that you can actively retract the exercise, but you can just click on the other tab and and continue.
That's no problem. It's just you sit there waiting for something you'll will fail. It's
Yeah. Yeah.
maybe it makes it more painful.
I think it's going to be a lot of trouble to actively ensure that you can kill the process that is running. Well, actually not. You're just sending a signal, right? But the problem is also it's not certain that you are contacting the same computer because they're the same server, because there are, I don't know, 5 or 6 machines running. So
Makes it a bit more difficult.
yeah, it's no,
Is this open source?
not yet. The platform is not yet open source, but they are thinking about making it open source.
As a massive program, not in English.
What?
All in Belgium was in much time. That's plenty.
Yeah, it's Flemish. So you know you can change the language, right? Okay.
Is there a difference between using LM for that or any with the filter with equality? Is the language doing things differently under the hood, or is there?
Oh, it's really difficult to say something about performance.
Yeah.
And so I have a lecture about performance in Haskell, and the recommendation basically is that you need to profile to be certain. Because lots of times you do some thing that you think like, this is going to make my program super fast, and then in the end you notice that the function is being called 3 times in the whole duration of your program. So it really depends on your program and how optimizations work for your particular case. And so what Haskell does, it does like all these kind of optimizations afterwards. So it might be that you are writing something that looks completely different, but in the end it's being compiled to the same thing.
So you need to have a regression test because even compiler upgrades, PSC upgrades can break everything, I suppose.
Well, yeah, kind of, but yeah, like in any language, right? I mean, if you, but
Regression test suite. Yeah.
yeah, but the profiler is really good, so you can easily see like every function, how many times it's being called, what's the memory consumption,
Oh, yeah,
and
it's built in.
yeah, it's built in. And you can also turn on and off the optimizations, of course, like in any programming language. Okay, so do we continue with the next exercise, the solution on the next exercise? For those people who are way farther, and that doesn't matter, but for the other ones, yeah, you want to see the next one? Okay, well, let's just look at this. Maybe this is a little bit interesting because I chose a very different way of implementing this one. So there is this AND function, and you can just give it a list of predicates, and so it's only going to give you back true if all the things are true. And so it boils down to the same as saying like x is smaller or equal than 0, and x is smaller than the width, and y is bigger or equal to 0, and so on. So this is like one way that you could also implement it. Yeah.
Is it safer to use round or use from integer to make our ints?
Is it safer?
Because right now the board is like the board parameters are integer.
No, the floats.
Yes, but the numbers
Yeah.
we put are integers. So do we want to round them, or will we want to play some Tetris in future using float movements and so on? Because right now when we round, we basically make them integers for the sake of comparison.
Yeah. Yeah. So actually width and height could have should have actually been just ints. That would have been better. But yeah. So does it make sense, the solution to you?
Yes.
Okay. Let me change that. So the best way it's a constructor color. So let me just look at the class. So no, that's not what I want. Class. Color. Yeah. Color. It's
To check F1, you can count on the number, on the length of the ones, right?
Yep. It's,
There are duplicates.
right. So tetrominoes versus blocks. Oh, you're saying like.
It's a list. I mean, it's not in there. So you can just add
core,
duplicates over the
functions.
same block. So you can just write down the length of those within the row to be sure that row is full.
You can introduce your own constraint, or it's basically like I'm guaranteeing every single time that I do this that I have called it unique or something.
Color functions.
Like,
let me-
I've done operations to guarantee that there are no
Okay,
duplicates.
cool. So make them distinct. Yeah.
Hmm. I don't find actual.
It has a lot of public constructors with no data constructor.
Yeah, I was looking for this. Tup, 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 tup.
I mean, under graphics.class, instead of color, there's like a lot of functions returning
Very
color.
confused with check.
Yeah, I know.
Otherwise, the line below it is. The country. Thank you. You're welcome. This is an outrage.
So yesterday there was somebody asking me why there is no pink. They call it rose. So so the unique color is the pink color. Unique color. There's no type definition. That's correct. Okay. Okay, so this took way too long, but so color, it's defined in gloss rendering internals data.color, and it's basically an RGBA. If you really want to know.
So, yeah, because what I was wondering is, are you able to say start with red and then apply some changes to it and get a new color?
Yeah, of course, you can do that. But there are lots of functions defined in. So, if you just go to the documentation of gloss,
Yeah, I did the same thing.
here, you can actually browse through all the documentation, and so the one that you probably want to check out is data.color. Yeah, and then so you can do add colors, and when you have two colors, you can mix them together. And so you can also dim them, brighten them, lighting them. So just have a look there.
Yeah, I will. I was imagining if I get through the Tetris, maybe I can make it like a bright Tetris where it changes through the rainbow as it falls or something like this. Could be
Yeah.
kind of fun.
Yeah, you could do all these different kind of things. So, for example, you could change the rendering of the block depending on the position where it is, stuff like that.
Look away for a second. I'll copy.
And so you can even like have a different kind of square. Like you could have like that it's not just a square. You could do some other thing there, of course.
Slice out this full row so those blocks are not in the final solution. Take all the ones below and concatenate with all the ones above and over. So that's
On board.
sort of like constraint. Yeah, basically.
Okay, so for okay.
One of these on the website doesn't have symbols from what we have. Some of the symbols are missing. Like for example,
okay.
I use move to implement one of the operations.
Really?
I think it was this one. Yes. So why is it not here? Submission. Yeah. So this submission, was it this one?
I don't know. I did the one.
I don't find it.
Yeah, the correct one.
Yes.
And then you can
Oh,
look
the
at the
code. Yes. So I had to define direction and move myself again to.
Are you sure? Because if you look at the hand in, it's there, right?
Oh, okay, fair enough. No, this is what I. There was something where I had to add.
It
I was
could
just
be, but
wondering about how this is implemented,
in this case, it's there.
Yeah.
In the
Was
previous
more
in Snake, really made the effort to sure that you didn't any of the previous solutions, and there,
okay.
which
That's what
but you don't see them these functions, but they are still there because
this-
they are in
this
a different
explains it.
module.
I did not understand what the helper was. Now it
Yeah.
explains it. Thank you.
Okay.